Okay, hey, we are going to go ahead and talk through some of this pretest. This is all review material that you should have seen in Algebra 1 and Geometry prior to you joining Honors Algebra 2 here. Okay, so some of these are pretty simple here. Which of the following which of the following equations is written in slope-intercept form? Okay, the answer to this would be letter B. Okay, we know the M is the slope, the B is the y-intercept. Okay, these other things, this first one is not slope-intercept form, but it is the slope formula for how to get the slope if you're given 2 points. Okay, this one you might not be very familiar with at all. This is standard form. We'll discuss this in chapter 2. And this is called point slope form. Okay, you'll notice it requires you to know the slope, and it also wants the coordinates of a point here. Okay, number 2. Okay, number 2 says find the slope of the line that contains the points 2, -3, and 1, 0. This is asking you for the slope. That is where you would use the slope formula. Slope formula is always rise over run, so you should always take your y coordinates and you should subtract those in the numerator. I will tell you technically the order that you subtract those in the numerator does not matter. However, what order you choose to go with for the y's, you must choose that exact same order then for the x's. Okay, looks like for this we're going to get 3 over -1, so we're going to say the slope is -3. Okay, number 3, what is the slope of any horizontal line? Okay, we're talking about lines that look like that. Those lines always have slopes that are 0. Okay, if the line was a vertical line, okay, that is when we say the slope is technically undefined. Okay, but horizontal lines have slopes of 0. Okay, number 4 and 5, state the slope and the y-intercept of the following lines. So since it's asking us for those two things, it's really ideal for us to rewrite the equation in slope-intercept form, which was what we had set up here for number 1. Okay, so to get it in slope-intercept form, you need to make sure the equation is solved for y. When it is solved for y, the coefficient in front of the x is the slope, the constant in the other term is the y-intercept. So in this problem, we would say the slope is 3. Typically, we use a b to represent the y-intercept. That is 5. Okay, on number 5, you'll notice this is not solved for y just yet. I recommend that when you divide both sides by 2 and you get over there to the right side, that you divide each of those terms separately by 2 rather than writing it as the whole side divided by 2. The reason I want you to steer away from writing it like this, it makes it a little bit more challenging to distinguish what's the slope and what's the y-intercept, okay? So we're not going to write it like that. We're going to divide this separately. Then it makes it very clear that we can see the constant, and then please keep in mind, if you do not see a number in front of the x, the assumption is there's the coefficient of 1, that would be your slope, and your y-intercept would be the 1/2. Okay, number 6. On number 6, it says find the equation of a line in slope-intercept form that has a slope of -2 and it goes through the point 1, 4. Okay. Now, there are a couple different ways that you can do this. I'm going to encourage you, since this is an honors class, I'm going to encourage you anytime you are given a slope and a point to start to get used to using this point slope form that you see in letter D for number 1. Okay, so I'm going to jot that down so that we have that here. Y minus y1 equals m times x minus x1. The places where you would make substitutions would be in for the x1, the y1, and the m. Okay, your x1 and y1 come from the coordinates of the point. Be very careful though. The y coordinate, which is the 4, is what you're plugging in for y1. Okay, so that's going to go there. Okay, the slope is -2. They gave that to us. And then the x1 is 1. Okay. Also, please just keep in mind that this formula has subtraction here and here. That's why I have subtraction, but had these numbers been negative coordinates, then we would have gotten a double negative and these would have been pluses, okay? Now, the ultimate question is we want to rearrange this in slope-intercept form. So once we do this initial substitution, then we just need to finish distributing the -2, okay? And then we need to get the y by itself. We're going to bring that 4 over, and we would have as our answer y equals -2x plus 6, okay? Okay, number 8, asking us to graph this line. Okay, the most commonly used equation when we're graphing linear equations is slope-intercept form. You do have to have the equation solved for y if you're going to graph it. So that's going to be our first step. We're going to divide both sides by 3. Again, I'm going to encourage you to divide these separately by 3 as opposed to just drawing one big fraction bar. Okay, once we have that, we should be able to identify that the slope, I'm going to encourage you to write that as a fraction so that we can kind of think of the slope in terms of rise over run, since we're going to be graphing this. Okay, and then we're also going to identify the y-intercept to be 4. Okay, when you graph this, you always want to start with the y-intercept. You're going to go up on the y-axis up to 4, and you're going to place that point there because we know that this line is going to cross through the y-axis at 4. Okay, the next step is then to have your pencil on the y-axis, glance over, look at your slope as a fraction. You're going to rise up the number of units in the numerator, and if the slope is positive, you will then run to the right the number of units in the denominator. Okay, so we're going to rise up 2, and we're going to run to the right 1. Okay, so if I were to do that, up 2, right 1, I'm going to repeat that one more time, up 2, right 1, so I have another point there. By the way, had this slope been a -2 over 1, you could still go up 2, but then you would go to the left 1. Okay, if any of you were thinking I was going to go down 2 and left 1, down 2 and left 1, that would have been fine as well. Okay, and then you're just going to go ahead as best you can and connect those points to get your graph. Okay, number 9, this is asking us to find the x and the y-intercept of the following graph here. Okay, I'm just going to organize my work here, x-intercept here, y-intercept here. Okay, now here's one unique thing about all x-intercepts. Okay, x-intercepts would be any point that would be located on the x-axis. And I'm just going to fill in some coordinates here so that you can kind of see maybe a pattern that's happening here. What you'll notice about all of these points, and I didn't fill in all of the coordinates, is what they all have in common is they all have a y-coordinate of 0, okay? So when you are finding an x-intercept, what you'll need to do to your equation is you'll need to plug a 0 in for the y. If you substitute a 0 in for the y into this equation, what's going to happen is that's going to wipe out that term. You're going to be left with 3x equals 4. You're going to continue to solve this for x, and you're going to get 4/3, which is kind of the same thing as 1 1/3. Okay, so that means that this particular line crosses the x-axis at 1 1/3, comma 0. Okay. Now, to get the y-intercept, you could do this one of two ways. You could rearrange the equation into slope-intercept form, and then whatever is in that spot for the constant, that's the y-intercept. Or you could make the same argument we made here and say, you know what? What all the points on the y-axis all have in common is they all have a 0 in the x coordinate spot, okay? So we could just plug 0 in for the x into this original equation. If you stick a 0 in for the x, this is going to get wiped out. We're going to solve for y, and we discover that the y-intercept would be at the point 0, 2. Okay, so this problem did not ask us to graph this line, but if it did, all you need are 2 points. So we could plot roughly 1 1/3 on the x-axis, come up to 2 on the y-axis, and then we could connect those 2 points together to get our graph. Okay, moving on to number 10. For some reason, 10 and 11 are like two of the most difficult problems historically for students when we go over this. Okay, anytime an equation asks you to solve for a variable, it just means get that variable by itself, okay? Now, this looks like the x is almost by itself, but I think what confuses people is they see the 2x, and this is what they think. They think, oh, I need to divide this side by 2, which isn't wrong, but then where they get confused is when they come over to the right side and then they get something that looks kind of ugly like this. You got a fraction divided by 2. And so here's what I'm going to encourage you to do. Instead of dividing the left side by 2, since I see I do have a fraction over here, can we think of a different way to get rid of the 2 from the left side rather than dividing by 2? And of course we know that if you were to multiply 2 by its reciprocal 1/2, that would cause the 2 to cancel. Okay, so whatever we do to one side, we're going to do that same thing to the other side. So if we are multiplying the left side by 1/2, we would want to come over to the right side and multiply that by 1/2 as well, and we get a very nice answer that doesn't look ugly like 3/2 divided by 2. Instead, 3/4 is the way we would want to write that answer. Okay, so over here, we are going to solve this equation for b. Now, we're not going to get a numerical answer because I automatically notice that there's a second variable in this equation. So all this means when it says to solve for b is you're just trying to get this b right there by itself. Okay, so you have to make sure the order that you move things to the other side of the equation is done properly here. The first step is we want to get rid of any terms that do not have b's in them, and so we would need to subtract 1/2 from each side. Okay, that gives us a 1/3 b on the left, 4a minus 1/2 on the right. Okay. Again, I'll say the same thing we just did in number 10. If you notice that you've got fractions over here, it's a really bad idea, and please don't write this down, to get rid of the 1/3 by dividing both sides by 1/3. This just looks ugly, and it's not considered a nice way to kind of simplify your answer. So when you have a fraction involved and you see particularly a fraction over here, it is always best to get rid of the number in front of the b by multiplying by the reciprocal. Okay, so I'm going to multiply by 3. That's going to get the b by itself. Now here's where you have to be careful. There are 2 terms on the right side of the equation. Both of those terms need to be distributed, or need to be multiplied by 3. So we're going to distribute the 3 to both sides, and this is a much better looking answer. Okay. Number 12, I don't know if you have any experience in geometry of simplifying radicals. When you have a fraction that is underneath a radical, the first thing you want to do is you want to make that square root symbol go both over top of the numerator and denominator. Simplifying a radical means to remove any square roots, radical symbols from the denominator. So you want to ask yourself, what could you multiply this denominator by? So that instead of having a square root of 3 down there, maybe it could just be a plain old 3. Okay? Well, the way square roots work is if you multiply a square root of 3 times another square root of 3, it's like you're squaring a square root. Okay? When you square a square root, what that does is that removes the square root symbol. Think about it. Square root of 3 times square root of 3 would technically be the square root of 9. And what's the square root of 9? Bam, 3. Okay, now whatever you do to the denominator, you though have to multiply the numerator by that exact same number. So I'm going to multiply the numerator by the square root of 3 as well, and that would give me the square root of 6 in the numerator. This would be a simplified radical. Okay, they're asking us on number 13 to solve the following equation using any method. Okay, I'm going to choose the factoring method. That's definitely something that we'll be doing quite a bit of this year. Okay, factoring, everything needs to be moved to one side, which it is. It needs to be in descending order, which we have. I'm going to go ahead and identify the a as a 1. That's the number in front of x squared. The b is a -5, and the c is a 6. Okay, since my lead coefficient here is a 1, I'm going to go ahead and go to my 2 sets of parentheses, put an x here and here. And I don't know if your Algebra 1 teacher kind of taught you this little x puzzle way of kind of sorting this. A times c, okay? A is 1, c is 6. I'm going to fill in a 6 up top, and then I'm going to put the b value, -5, in the bottom. You want to think through what are two possible numbers, that's what ultimately we're going to be putting here and here, that are both going to multiply to be 6, but they're going to add to be -5. Okay, that's what we're trying to think through. Okay, those two numbers would be -2 and -3. Those will add to be -5, but those will multiply to be a +6. Okay, once you have this factored, then you're going to proceed to take each factor, set each factor equal to 0, and we get two answers of 2 and 3. Okay. All right, these last two are right triangle trig problems here. Okay, sine, cosine, tangent. You probably remember the acronym SOHCAHTOA. Okay, we're going to find the missing side of the triangle. They only want us to find side x. We're going to use the 65-degree angle. The 8 is the hypotenuse. The x would be considered the adjacent leg. That lands us with cosine, since that's adjacent over hypotenuse. So I'm going to set up the fraction cosine 65 degrees equals x over 8. I'm then going to cross multiply. Now here's the catch. If you go to type this into your calculator, you must be in degree mode. Okay, you have to be in degree mode, not radian mode. This gives you roughly 3.38 units for that answer. Okay, and lastly, it wants you to find sine of 60 degrees, not typed into your calculator, but in simplified radical form. Okay, so I'm just going to draw a right triangle. Okay, I'm going to go ahead and label that this is 60, which automatically means that's 30. This is a special right triangle, 30, 60, 90. Okay. I can technically pick any number I want for my short leg. Okay, the short leg is the key leg in a 30, 60, 90 triangle. That's the leg opposite the 30-degree angle. So I'm just going to make that 1. Okay, now the relationships to the sides in a 30, 60, 90 triangle work this way. You take whatever the short leg is and you double it to get the hypotenuse. So my hypotenuse would be 2 in this example. Okay, it wouldn't matter what you pick the short leg. You could pick whatever you want here. You're going to double it to get the hypotenuse, and then you multiply the short leg by the square root of 3 to get the long leg. Okay, now here's the question. What is sine of 60 degrees? Okay, so this is the angle. Remember, sine is SOHCAHTOA. That's opposite over hypotenuse. So I'm doing square root of 3 over 2. Right there is sine of 60 degrees as a simplified radical. Okay, that is the explanation of the review, the pretest there for you.